Yes. Yeah, I read. I saw your name, so I didn't read it. Yes. Okay, so let us start, continue our lesson. This is just a quick review. This is, by the way, at the level of Math 2C. At this level, I hope that you are not making any mistakes in these kind of simple calculations. And this is something we learned this year about the degrees of polynomials. Then we will continue a little bit about polynomials today. But mainly, this is a very... let me just do it one by one. So number one, if you want to solve it, so it's very important you haven't done even one single mistake here. So number one, you have 4a minus 2a times a plus 2. Yes? So some I have seen, this is probably the only mistake some people do. They do this one first. If that's the case, that's wrong. Because if I ask you what is this, you would say this is a subtract between this expression and that expression. It's a subtraction. And then I ask you what is this, you would say it's a product. And we know that the product has priority. And that's not, of course, very strange. Because if I ask you to subtract two numbers, what do you expect from me? You expect me to give you the numbers, then I ask you to subtract them. If you don't know the numbers, well, how do you want to do subtraction? So when I write 2 minus, for example, 3 times 5, this subtraction is between these two numbers. So if I want to do this operation, I need to know these numbers. Of course I know this number. I have to do this number first in order to be able to subtract them. So it means that this product has the priority. So this is not something that you have to memorize. This is very natural. Yes?
Wait, when you write decimals, do you write them with a point or a comma? Because it was kind of low, so I thought almost it was a decimal.
No, I will do this. In the test, by the way, this is a little bit tricky. In English way that you write, decimal point lies here. And the product lies here. Yes?
Yes.
And of course I will not use Swedish. In Swedish, this is why probably you use comma.
Yeah.
And that also would be a matter of confusion. For example, if you have a point 2.5 and then comma 3.5. So what's this one then? So that's a point whose x-coordinate is 2.5, but this is, and then 3.5, yes?
Don't you usually have like the I don't remember what club it's like a 2 dots. What is it called?
Semicolon.
Yes, a semicolon.
No, semicolon is not allowed to use here.
Okay.
Semicolon in mathematics means ratio.
Means ratio.
So when you write this semicolon 1, it means that something is being divided so that one part is 2 times larger than the other one. So all of these symbols have their own pros and cons, you know. So but in English, this decimal point comes here and the product comes here. When I type them, it becomes clear. Yeah. But to avoid this confusion, especially when I'm handwriting, might be it's a good idea to use cross for product, not dot. And then I always use point. So let us have this convention, okay? So whenever we have that, when I want to write a product, I write it as a simple, as a cross here, yes? So here, so if I want to write 0.5 times 10, I would write something like this, okay? This is easier to understand. Okay, but that is what we have to do. Anyway, so if I want to do this, I have to calculate this one first because I need to know the number in order to be able to do this difference, yes? To this subtraction. And then, of course, this gives the priority to the product. So this is coming naturally, yes? It's not something that you have to memorize. So this is the case. So if you want to solve this, if you want to really do all the details, which you don't have to, I would write for a and then I will keep minus sign because I told you that my goal is to do the product first. Yes, as in numbers. In numbers, I have to do the product 15, and then I will do this operation. So here, I have to keep for a and the operation of subtraction the same, and then I have to apply this here. So what is that? Then it means that I have to have a pair of brackets around that, then 2a multiplied inside, which becomes 2a squared, and then 4a. And then you have to remove the pair of brackets, but you need to remember this crucial fact that this negative sign is not just only for the first one, that's the whole expression minus. So it becomes minus 2a squared, again minus 4a. And then this minus 4a and that 4a are gone, so what is left for you is minus 2a squared. Yes? But, of course, if you want to do it quick, I would agree that if you write it in this exam, this one, just multiply minus 2a inside from the beginning. But I think it's important to understand what you are doing. So in the exam, especially, being very quick is not very important. Being very precise is actually important. So that is the answer. If you haven't got that answer, it means that you have some weakness here. You need to teach it yourself. Where was your weakness detected? And try to. So this, I wouldn't even accept that if you have a minus sign mistake, because this question is so simple that I really expect you to be able to write it minus 2a squared exactly. Okay, so here, for example, if I want to do this, how should I interpret this question? You see here, how many packages you see. This is one package, this is another one here, and this is another one. So what I am doing, I have three numbers written in a little bit long way, but I want to subtract and add them. So if I want to add 5, I want to do this operation, what do? I need to know these numbers, then I start subtracting and adding them. Here I don't have any problem, I already know this number. Here I do not have any problem. Even though I don't know it, but I cannot do anything for this, because 2 times x times y squared, this is the only thing that I can do here. So the only problem is this, the middle term. So you need to patiently write the things, the copy and paste 5 and then minus. Here I have 3 numbers involved, I want to multiply them. So you learn that if I have 3 numbers involved, I can multiply the first one by the second one, get the answer, and then multiply the answer to the third one. So let me just copy and paste this, and let me multiply 3 inside the first pair of brackets. So it becomes what? 3x plus 6y, and then I have x to the power of 3 minus 2y squared, and then at the end I will have 2xy squared. But again, I cannot continue unless I do this product first. The priority is with this product. So it becomes 5. I keep the minus sign here. I open a pair of brackets for multiplying this inside. So what happens? It becomes term by term. So it becomes 3x to the 4 minus 6xy squared plus 6yx cubed. And finally minus 12y to the power of 3. And then I will have plus 2xy squared. So what I do, I ask myself, is it possible to simplify this expression before proceeding any further? You will see that the answer is negative because none of them are similar. So what can I do? I have to open it up. But again, this minus sign is not just for the first term, it will affect all the signs inside. So it becomes 5 minus 3x to the 4 positive 6xy squared minus, let me write it as in order, x to the power of 3y, it's not compulsory of course, and then minus times that it becomes positive 12y to the power of 3, and then I will have 2xy squared. Yes? Do I have any similar terms involved here?
No.
No? That's the end of the problem. Yes?
The x,
Do I
y
have?
is 2xy squared. 6.
Yes, thank you. I didn't see that. So these two are similar, exactly. The letter parts are actually xy squared and the other one. So it doesn't matter which one do you want to write. But for example, if you this is not compulsory, but just I want you to know about that. Because I have 2 variables, I can write it in a standard way in 2 ways. By standard, I mean that I will start with the highest power and write it in the descending order. But because I have 2 variables, I have to decide which variable I want to do this with. Okay, my preference is to start with x, which I don't have any problems. So I will choose the highest power for x. So this gives me this term first. This is not mandatory, I want you to know. Okay, and then what is the highest power of x after this? Is this one. So I will write this term after that. Do I have any x squared involved? No. Do I have any x? Yes, these two terms. So I will write 8xy squared. Is anything left? Yes. So it doesn't matter. So I would write 12y cubed. And then I have a 5 there. I hope that I haven't done mistakes. So the order is not important. If you write it in the exam in a different order, that's acceptable. But if you want to be organized, you need to usually write them. It's good for other things that you want to do with polynomials, that you write them in descending order. If there is one variable, that's clear. You have to choose that variable. If you have more than variable, you need to decide which one you want to write with respect to that. For example, if I wanted to write with respect to y variable, which term should I write first? The highest power of y, which is 12y3. Then this will come, then this will come, and then those two terms. Yes, that's not compulsory. Okay, any questions here? How many of you got exactly this answer? Of course, except the order. That's good. But if you haven't done that, even if you have made a small mistake, you need to put a question mark, I don't know, you mark over next to it so that you can review the problem again. Okay, so let us do this problem. So I can clean this part. These whiteboards markers are very nice to write with, but it's very hard to clean. I need to decide which one actually at the end dominate the other one. My interest in writing or suffering cleaning. Yes. Yeah. So m minus 3n times 2m minus this one. So how do you look at this problem? Of course, I have one subtraction operator. If I want to do this subtraction, I need to know the left-hand side. I need to know the right-hand side. Then I can do the subtraction. So this means that this priority is given with this product and this product. But that is just a simple product between two numbers. That's a product between three numbers. That's it. So what I do if I want to solve this, in principle, of course you don't have to, but let me just a pair of brackets for multiplying these two. So I multiply, it becomes 2m squared, and then this one that it minus 5mn, and then this one by that one is positive 6mn, and then finally this multiplied by that is 15n squared. Yeah, please correct me if you see I'm making some mistakes. And then I put this negative sign here. And by the way, writing properly is very helpful, especially for the novice students. If you write it messy, you really mess up. Okay, so you need to write it properly. So try to have a better handwriting, not a very beautiful one, but very clear one. Okay, so minus 3, I don't know. If I want to, I can multiply these two first and then the answer. I have done multiplication this one first. Let me just for practice multiply these two first. It doesn't matter at all. So I have decided to keep minus 3 here. Let me multiply these two. So this becomes 3m squared. So you have 2 degrees of freedom. Multiply these two first, or multiply these two first, or even multiply these two first. It doesn't matter. So 3m squared minus mn, and then I have plus 18mn, and then minus 6n squared. Okay, so you shouldn't be in a hurry. So first of all, I simplify this expression. So let us keep the pair of brackets still. So I have 2m squared, and then I have minus 5mn, positive 6mn, which is what mn? Yes?
It should be a negative.
Yeah, negative.
Where?
Minus 6mn.
Yeah, minus 6mn.
I couldn't follow. So here?
No, on the other side. Other side.
On the left side.
In the middle of the parentheses.
Here?
Yeah, that's supposed to be a negative.
So 2m squared minus 5mn minus 6m. Thank you very much. Thank you. So then that was exactly the correct moment for that. So this becomes minus 11, so mn, and then plus 15n squared. And then here I also prefer to simplify, so it becomes minus 3. If I simplify that, it becomes 3m squared plus 17mn minus 6n squared. Okay, let me double check everything again. So 2m squared minus 5mn minus 6mn, that's correct. And the other one is 3m squared Yes. And now, do I need this pair of brackets? No, so let us just finally remove it. Of course, you can remove it in the previous steps as well, but I just want you to understand how is it going. When you have a positive sign, you really don't need to be that much careful. But you have a negative sign, you have to be careful. So here I multiply, in principle, I have to multiply 3 inside and then remove the pair of brackets with the negative sign behind that. But let us just do it in one go. Instead of that, I take minus 3 outside. So, but sometimes I have, the reason that I want to avoid that, because I have seen some students, for example, when I tell them multiply minus 3, they write it in this way. Okay? Be careful, this is wrong. Because what you are doing, technically it seems to be right, because you are telling yourself that I am multiplying minus 3 inside. So I have done the multiplication left. And then suddenly, what you read between them, it's a product, which is not correct. It's not supposed to be a multiplication. Is that understandable?
Yeah.
So if you have A minus B, if I decide to put minus for B, if I write it in this way, that is wrong. I have to remember to put a plus sign and then put the minus sign for B. So this, I have seen some students make a mistake here. So if you are completely safe here, you really understand, so don't do it in 2 steps, because it's making the question actually longer than necessary. So I just multiply minus 3 inside, so it becomes minus 9 m squared minus 51 mn and positive 18 mn squared. Are there similar terms? Yes, here. So 2m squared minus 9m squared minus 7m squared, and then minus 11 mn minus 51 mn, it's minus 62 mn. Yes, and then 15 and 18 is 33 n squared. Double check again. Don't forget, usually double check these things, because that would be a pity, lose a point for nothing. So you see I made a mistake myself here. So this is probable.
I think it's correct.
Yeah. And if I have chosen, in this way, that's also a standard. But a standard in terms of m. I have chosen the highest power of m first and then. Okay. Okay, but I don't think the next problem is hard. This is actually Math 2C, Math 2C, about the polynomials. But here we learned something which we're not that sensitive in Math 2C about, and that is the notion of the degree of a polynomial. So the degree of a polynomial, do you remember? It was defined to be the highest power of that exponent. Of the variable. So here, of course, you can multiply and simplify to be able to read the degree, but that's not probably a practical way of doing that. So you need to be able to understand what will happen if I really expand and simplify. What would be the highest power? It's very, very simple. If I want to have the term with the highest power for x, it's clear where is it coming from. It is coming from when I am multiplying the highest power of this by the highest power of that. And if I do that, what would be the highest power that it is actually produced? It's 3. So, but of course the rule of thumb is to add the highest power and the highest power, yes? So it's very simple. The degree of this polynomial, so you can write, this is the symbol that you use, degree of p of x is 3. If you want, you can write 1 plus 2. So what is the degree of q of x? What is your answer for that? Of course, raising it to power 5 is very hard, because it will involve 243 terms, because this will be 3 to the power of 5. So if you want to really expand and read the highest power, it is possible, but it is actually practically really inefficient. But do we really need to do that? No. So what's the answer?
15.
It's 15. I wrote the formulas for you, but I don't want to just memorize the formulas. You can visualize this. It means that I have written this 5 times and I'm supposed to multiply them. and I am looking for the highest possible value for the exponent of x. So it is clear that I have to take x cubed from each and multiply them 5 times. So this will produce me x to the power of 15, and I will not be able to have higher power than 15. Agree? So then it means that the degree is 15. So what is the degree of r of x? So what is the degree here? Yes?
Well, I got it to 54.
54. Yes.
Same here.
Yes. Why is that? Because you yourself, you see that this is a second power. I am raising it to power 3. Of course, there are many details involved, but then it comes to the highest power. It is very simple. You just imagine you multiply x2 by itself 3 times. So 2 plus 2 plus 2 becomes 6. So a degree of 6, which is the highest power, is coming from this, and the degree of 48 is coming from that one. Is that understandable? And now I have a degree of 3, and I have a degree of 48, and then I want to multiply them again. So the highest powers will actually contribute here. So what would be the answer? As you said, let me just write it a little bit detailed. So I will write it as 3 times 2 plus 12 times 4. So this becomes 6 plus 48, and the answer is 54. Okay, and finally the last one. Yes?
Yeah, I was wondering on the exam, how are we supposed to like show how we get?
No,
to
you
our
don't.
answer?
If I give this in the exam, probably the final number is important.
Okay, so we just write our final number. That'll be okay.
Yes.
Okay.
Unless I explain, ask you to explain, which usually I don't know, because if you can find the correct number, that's enough for this. It means that you know the process of finding the correct number.
So you don't need to. We don't need
You
to.
don't
we just
need,
write
you
the
really
final
don't need to do it.
Okay.
So here, what happens here? In addition, you need to be a little bit careful, because there is no equality. Do you remember the degree of the sum of 2 polynomials is not necessarily equal to the maximum. It is less than or equal to the maximum degree, yes? So that inequality makes it a little bit problematic, but this is very easy to understand. When it becomes smaller, when you are unlucky and 2 terms with the highest power cancel each other. So for example, one of them is 2x cubed, and then you have minus 2x cubed somewhere else coming, and they cancel each other, and the second degree will be left. If this does not happen, that the highest power cancel each other, so don't worry. This is exactly equal again to the maximum. Yes? So how should I understand that? That's also not hard to understand. If I ask you, let me just clean this. If I ask you, can you imagine what is the highest term, not just power? Can you tell me what is the highest term? What is the, sorry, that's not a good, what is the term with the highest exponent of x? If you multiply this 17 times, what do you think you will get at the end for the term with the highest power of x? Yes?
51.
So that would be just the power. Power is 51. But I'm not just talking about the power, I am just talking about the whole term. Whole term means the x part and the coefficient.
Okay.
So what would be the coefficient then? Yes?
34.
No? Sure. Why 4? I was still telling it in Persian. Yes? Why is it 4? How did you bring?
34, I said.
What?
34.
Come on, Abdullah. I know what 2 to the power of 17 is not 34. Yes.
So
but that is your famous 34. Yes. So 2 to the power of 17. Yes? So this is the highest term coming from here, and then you multiply it by the highest term here, which becomes 2 to the power of 17, x to the power of 53.
Yes.
I don't want you to, I want you to imagine this. I really don't want you to write this down. But one thing is clear. If I ask you what is the highest term, what is the term with the highest power, this is the answer. If I ask you what is the highest power, 53 is the answer. Okay, be careful about this. And then I want to do the same thing here. This is one polynomial, this is another polynomial. Can you tell me what is the term with the highest power here? What is the highest exponent, first of all?
Exponent?
Yes?
48.
48. But if I ask you what is the highest term, then you write 5 to the power 4 as well.
Yeah.
Yes? And now, look, here you have a polynomial, a very complicated polynomial, but the highest leading term is this term. And then you have also a complicated polynomial here, but the leading term is this term. And now, is there any chance that they cancel out together?
No.
No. So what is the highest power you see at the end is 53, and that would be the degree of your polynomial. So the degree of this s of x is just simply 53. Again, I will ask you find the degree, but you need to understand. I don't know, might be these degrees are the same, so, and these are unfortunately opposite to each other, so they will cancel out. Then you have to be careful. But other than that, you don't really need to be careful. Yes? Is that understandable for everyone? Okay, now, I don't know, let me tell you another thing about the polynomials, which probably is also a little bit new for you, and is the notion of identical polynomials. Of course, from the English word identical, you might guess what's happening. So, when do you think two polynomials should be called identical?
When
It's
they
the
same.
Yeah, it's a little bit a strange question. Yeah, they have to be exactly identical. Yes, they should be the same. But if I want to give a definition for that, it means that if you have two identical polynomials, it doesn't matter which value for x you choose. Then you calculate the left-hand side polynomial for that value of x, and if you calculate the right-hand side polynomial for exactly the same value of x, the answers will match at the end, not just for one value, for all possible values of x. Is that understandable? So that's also another way of, but of course if they are identical, they should have this property. But there are some questions later you will face, but let me just tell you here. For example, let me see. And for example, let me ask you this. If I give you two polynomials, there are questions that I can ask you in this form. Okay, ax plus b, and then I will give you qx minus 2x squared plus 3. First of all, do you think that these polynomials can ever be identical?
No.
No. One reason is that, what is the degree of this polynomial? 2. And what is the degree of this polynomial?
1.
1. Or, this is not guaranteed to be 1 because we don't know about a. It happens that sometimes might be a is 0. If a is 0, what is the degree? The degree is 0. Yes, but this is the degree 1 or 0, but the degree here is definitely 2. And if two polynomials are supposed to be identical, their degrees have to be the same. Okay? But what about this one? Do you think that if I give you this polynomial, ax squared plus bx plus c, and I give you this polynomial, 2x plus 5, do you think that for some choice of a, b, and c, these polynomials can be identical? Can I make them, by proper choice of a, b, and c, can I make these two polynomials identical?
Yeah.
Even though apparently this is a first degree polynomial, this is a second degree polynomial. But are there choices for a, b, and c so that this polynomial becomes identical to this polynomial?
Yeah.
Yes, for example, if I want to do it, then a has to be
0.
0, and b has to be 2, and c has to be
5.
By this choice, I am making these two polynomials identical. Okay, that's it. So at the end, identical polynomials after expansions look exactly the same. Yes? But the point is that sometimes you have them before expansion. For example, let me give you this. This is what I want you to understand, and then we will move to the next part of the lesson. So, example. Determine a and B such that, so let me throw this again.
I can take it.
You really want it?
Yeah.
I can give you a new one.
No, it's fine. Thank you.
Yes. Let me give you this as a
Oh,
present.
thank you. You're so kind. Thank you.
Welcome. Yes. I can just, because I bought this for myself, so I can just give it to you. That's mine, not the school's property. Okay, so determine A and B such that this happens. The polynomials
Oh, it's so dark now.
the polynomials, let me see, P of x is equal to x squared plus 2x, and Q of x equals to A times x to the power of 3 plus 1, and then plus this, bx plus c multiplied by x plus 1, be identical polynomials. Be identical. So these kinds of questions I want you to know. So you might say that because this is very simple. So I have given you two polynomials. One is exactly in its standard form, but one is not in its simplified version, standard form. Now I am asking you to determine these coefficients A and B, and C, by the way, sorry, because there are also a C involved here. Determine A, B, and C such that the polynomials, this and that, are identical. So this is one of the type of questions that you might face for this topic. The first step to solve this question is to write both of them in the standard form and then compare the coefficients term by term correspondingly. So if you want to solve this, the first one, P of x, is already in its standard form, but Q of x is actually not in the standard form at all, so I have to make it standard. I have to write it in the standard form. Standard form means choose the variable. Of course, here we have only one variable, and then start writing the terms in descending order of the powers. So this is already in the standard form, so let me just write it here for you. P of x is equal to x squared plus 2x. And then Q of x is equal to, what is the first step? I have to write it in the standard form. So I have to be good in multiplication and simplification. So I multiply this, what happens? It becomes ax cubed. And then I multiply this, it becomes a. And then I have to multiply these two polynomials. So bx times x is bx squared. And then bx times 1 is bx. And then c times x is cx. And then c times 1 is c. You need to listen to this part good. So this polynomial is a polynomial in terms of x, but in a standard form I cannot have more than one term with x3, more than one term with x2, more than one term with x, and etc. etc. So this is already in that form that I want here. Ax cubed, I write it. How many terms are involved for cubic term? Only one, so let me just write. How many terms are involved for the quadratic term? Only one, so let me just write. But how many terms do I have for the first degree term? 2. This appears 1 with B, 1 appears with C. You need to factor x out between only those two. Okay? So you write plus, you put an x here, and then you write B plus C. And then you have a C at the end. So this is the standard way that you need to write your polynomial. So if I give you a polynomial which is not in a standard form, this is an easy task. You expand everything and collect the terms with the same power of x in one place. Yes.
What happened to the other A?
And that's my mistake. I have to put a as here. Thank you very much. But you see, it is in descending order. The highest power is 3, the next power is 2, the next power is 1, the next power which is not written here is 0, x to the power of 0. But this is important. Do not have the same x or x cubed different places. You need to collect them based on the power of x. You are not allowed to factor x from all of them. No. X's together, x squared together, x cubed together, term by term. And then compare the standard form of this polynomial with this polynomial. And try to make them identical by fine-tuning the values of a, b, and c in the problem. So for example, by comparing this, immediately you understand what should be the value of a. What is it? Yes?
0.
0. Because I have a cubic term here, I do not have any cubic term here. So I cannot create a cubic term here. The only way I should get rid of this cubic term here. So you choose a equal to 0. Okay? What would be b? Yes?
What?
No. I guess yes, thank you. Because you are comparing this with that one. Yes. This is x squared. The coefficient of x squared is 1. The coefficient of x squared here is b. They have to match. Otherwise, they cannot be made identical. Thank you. Okay, and then what can I do else? So you see the coefficient of x is b plus c, but the coefficient of x is 2. So it means that b plus c should be equal to 2. And then finally, the leftover, the number without x is c plus, the constant term, by the way, this is called. The constant term is c plus a. What is the constant term above? 0. So you see, I face a problem that you also studied this in Math 2C, solving system of equations. Sometimes this system doesn't have any solution, sometimes it has. If it has, it means that I can make them identical by those choices. If it is not, you say that it is not possible to make these two polynomials identical. Yes? So let us see. A is 0. I don't need to do anything. A is already found. B is already found. I want to find C. There are two equations that I work with when it comes to C. Okay? For example, I choose B equal to 1 and put it here. What is the answer? It becomes 1 plus C is equal to 2. What's the answer? C is 1. But don't be in a hurry, because all these conditions should be satisfied simultaneously. There is no guarantee yet that the last one will work, and you see it doesn't work. Yes? Because C is what? 1.
Yeah.
But when I put it here, A is 0. 1 plus 0 is 1. It's supposed to be 0. So it is not possible. Yes? So you see when I put it here, 1 plus A, which is 0, is equal to 0. This is the symbol that I use for contradiction. Yes? It doesn't make sense. 1 plus 0 is equal to 0. Yes.
Is that like the official for contradiction?
Not globally accepted. I just picked it from the professor that I was listening to.
Okay, so it's your personal convention.
Yeah, might be. Yes.
Yes.
Okay, so you see that what you write at the end as the answer. This is some people say that this is a wrong problem. No, you should say that these two polynomials. These polynomials cannot be identical. So you shouldn't look for any particular number. It is not possible to find suitable values for A, B, and C so that these two polynomials become identical. Yes?
Aren't there any imaginary numbers that work?
No. because you solve this system, you are finding all solutions, and you see that those solutions are simple, not in the set of complex numbers. So it means that no, it is not possible to find any. Yes?
Why did you write C plus A in one bracket?
Because they doesn't contain x. I am supposed to collect them with the same power of x. So x cubed, when I look here, x cubed appears in one place and its coefficient, the single coefficient is a. Okay? For example, x squared happens at one place with coefficient b. X happens at two places, so I write x and I add these two. And then there is nothing here, doesn't contain x, this doesn't contain x, so they can consider to be the same. In one group, not the same. Okay, any questions?
No.
Okay, yes, this is good to know about polynomials, yes?
Oh, I was just wondering. So in the test, there is a possibility that it won't work or
Or
that it
work,
will work.
yes.
So we need to find it out
Yes,
always.
yes.
Okay.
Okay, now the next part of the the book is actually, I think the logic is very nice in this book, because the point of calculus that we are going to study later, the notion of limits and derivatives, is mainly because we want to be able to draw the graph of different functions. So far, if you want to draw the graph of a function, what can you do? You can have the formula for your function and give some points to it. I just want you to understand the problem is not simple at all. This is why we really need to invent a lot of mathematics to be able to capture the main essence of the graph of a function. For example, let us just start with a simple one. If I ask you to draw the graph, you see there are very, very big problems here. If I want to ask, except for this one, if I ask you to draw this, more or less you can do it precisely. Because from your previous math knowledge, you realize that if I have a first degree polynomial, the graph would be a straight line. Okay? And if I guarantee that your graph is a straight line, in practice, how many points do you need to detect on the line so that you can draw the precise line? Yes? 2 points, yes? Because if you know the 2 points, you put the ruler next to them and then just draw the line. But when it goes even 1 power higher, then the problem starts actually. I want you to understand the main problem, okay? We are not going to address how to solve them. You need to be patient. After learning derivatives and things like that, we will come back to it. But if I ask you to draw this graph, this idea will break down. First of all, of course, you have some knowledge about this one. You know that this should be a parabola. Okay? But assume that you really, this is the logic. Assume that you really don't know anything about the graph of the function. What you have is just the formula for the function, and you want to be able to draw a graph of the function which is qualitatively reasonable to the real graph. Okay? So for example, if I want to do this, for example, I put x equal to 0, what do I get? Y equal to 0. So I will highlight this point, for example. And then if I put 1, I get y equal to 1. Yeah, so if you want, I want to make a table for you. So I put 0, I got 0. I put 1, I get 1. This is another point. Yes? For example, if I put minus 1, I get again 1. So this would be another point. So the problem is that what should I do with these points? How should I connect them? This is the main problem. I want you to understand that. Understanding is part of this lesson today, because there is no calculations going on in this lesson. So you might say that I connect them like this. So this is something we want to avoid, because the real picture is not so sharp. Here you have a sharp point if you do it like this. But if you do it, for example, with Geogebra, you see that you will produce a very smooth curve. This I want you to understand in the future, that even if this formula is complicated, you can do some analytic work to understand what is the main features of the graph of the function. For example, do you really have sharp points somewhere, or the graph is going smoothly? We don't know. We do not have enough mathematics in our hand to be able to answer this question at this level. We will gradually learn that. I want you to know the whole point of Math 3C is taking you towards the point that you should be able to qualitatively draw the graph of a function in a nice way. By hand, for example. A sketch, not precisely. Okay, might be another thing. So you might say that, okay, let me choose another. So for example, you say that no, this might goes in this way. By the way, I have a lot of different ways from going in this direction. Of course, you have idea of this graph in your head, so you see that this is reasonable. But how do you know that this is not going in this way? How do you know that this is not the graph? You see, how do you know that this is not the graph? So you might say that why this is sharp point. Okay, how do you think that this is not the graph? Okay, so everyone can, because we are, by the way, it's very hard for computer to make a difference between these things by just detecting, okay? But for human eyes, for human brain, it's very easy. There is some property here that this one doesn't have, and that is probably this sharp point. Yes? So you might say that one way is to find another point in between. You are right. I put 1 over 2 here and I get 1 over 4. And when I find 1 over 4, 1 over 4 would be here, not there. So then you will see that this is not the correct one. But it doesn't matter how many points you get involved with. So because, for example, if I have 3 points, if I make this point, but the graph can also go like this.
Yeah.
And you say that no, I will detect another point to rule this out. But how many points you want to detect to rule all possibilities out? It's not possible because it should be infinitely many. Is that understandable? So for being able to draw a graph of a function, it is not a practical way to have infinitely many points. Well, of course, if you choose 10,000 points, then you might make a lot. So you will be more precise than choosing 4 points, of course. But still, this is not enough. Let me just describe this one for you. For example, by the way, this is by even Geogebra, if it is not programmed in the right way, is not capable of doing that. For example, you draw a graph of a function, and you might say that the graph is parabola by looking at the display. For example, it looks like at least like parabola. But who knows that? Because it might happen that here you are working, for example, around x equals to 1, but how do you know that what will happen for the graph of the function when x is equal to 1 million? 1 million. Because it is not fitted into the screen. Okay? This is something that I want you to understand. If you do not know the mathematics, you will not be able to understand that unless you need to move with Geogebra. And on the other way, you don't know what is going to happen. If it doesn't happen in 1 million, it is not guaranteed that it doesn't happen for 10 million. So you cannot sit down and just move to the right, and if you don't detect anything, go back, move to the left. You see? This is what I want you to understand. Even if you have a very good computer in your hand and you draw the graph of a function, that is the graph of the function around the points that you are looking at. Still, there is a chance something interesting. For example, by looking at this graph, the first intuition is that might be this will go forever. This is the first intuition. But how we know that? For example, might be later when you're out of the display, this is going to go back. Do you understand what I mean? So by looking at this graph, because you are limited in your screen, you might have this impression this is the real graph. But if you zoom in, might be something interesting again can happen. So these behaviors I want to be able to detect in the future. Okay? Is the graph is always going up? Is it always going down? Are these up and down turning points? So these points are very important for me. So if I give you the, so for example, if you draw this graph, if I want to tell you pick 2 points, which is more important here than the other points, to be able to draw the graph, which points you choose? Yes? The turning points. Yes, the turning points are more important for us as a tool than this point. So you see, okay, this point is also good, that point is also good, but the turning point is very important because you know something about the behavior of the graph. You know that the function goes up to here and will return back. Okay? If I can show you that for this graph there are no other turning points, then that would be a reasonable picture for the real graph. Because if there are no other turning points, it means that the graph is boring after that, because it will continue forever and this will continue forever. So what was the important points you were able to detect around this? And you are guaranteed, if you have enough tools in your hand, you are guaranteed nothing interesting will happen after this display. Nothing on the left, nothing on the left, right. Understandable? So I want you to see that even though, because this century we are working with computers, we are taking everything for granted. We just draw the graph and say that, okay, why should I bother to learn so much to draw the graph of the function, because I can just draw it with GeoGebra? The short answer is that GeoGebra is always able to give you the graph, okay, around the points that you are looking at. Okay, but of course GeoGebra is programmed in a way that it knows about the real features of the graph. So if you ask them to draw, probably it will take you to the more interesting part of the graph. But the reason that GeoGebra can do that is because it is programmed based on mathematical arguments. Is that understandable? Okay. So, one thing that is important for you to understand here in this concept is this. If I want to make this short, the goal of this lesson is to understand some terminologies about the graph of functions, but this would be a primary school task because the logic is the other way around. Here, I am assuming that the graph is given to you. I want you to understand some terminology here. Okay? This is a very primary task. But the logic would be completely opposite. Later, I will give you the formula and I will ask you to draw the graph. Okay? That would be the hard part. Yes? But for the time being, don't worry about that. First of all, you need to know the notion of tangent lines, tangent line, or a secant line. So these are the words that I want you to know. Of course, all of you have a feeling of a tangent line. It comes from the circle. Yes? If you have a circle, yes, what would be the tangent line? The tangent to the circle is a line that touches the circle exactly at one point. So that is called the tangent to the circle. More or less, I want to take this intuitive idea for any curve. Yes? For example, if I have this curve, yes, I can take a point here and I can draw a tangent line. So it means that I am looking for a line which touches this graph at the vicinity of that point at exactly one point. So that is a tangent line. Yes?
We discussed this in physics recently.
Yes, that's completely related to that. We will see that. So that is the tangent to this curve. Yes? But what is the meaning of secant? Secant means that for example, I take this one. Here, secant is something like this. It is actually intersecting the curve at more than one point. So here, if I want to draw a secant, for example, you consider this a secant. So that orange line is a secant to this curve. This red one is a tangent to this curve. This point is very important for the tangent. This is called the point of tangency. Yes? The point of tangency. So these are the words that I want you to learn. So we will work with these words a lot. there is a main big difference between tangent to a circle and tangent to a curve. Can you imagine what is the main difference? There is a big difference between the tangent to a circle and tangent to a curve. Okay, let me just tell you what I mean. It is not possible for the tangent to a circle to be a secant as well. In a circle, either we have a secant line, and that's a secant, or we can have a tangent line, but that's always a tangent line. But for a typical curve, it might happen that a tangent line is also a secant line simultaneously. How? For example, if I just draw this line, tangent here, it will also be a secant. Yes? So is this green line tangent to this curve, black curve? You should say yes. Then I can ask you where the point of tangency is. You should show me this. But also there is another intersection between the green and the black one, which is this point. But do you think it is reasonable to call the green line to be tangent to the black one at this point? No, they are intersecting. So this is the main difference. This cannot happen in a circle. In a circle, tangent is always a tangent, secant is always a secant. But in a curve here, if this black is going in this direction, always, assume that this is the case, then this is always a tangent line. But this green one is not only a tangent one, but also a secant one. Is that understandable? Yes?
Could you say what a secant line means by definition?
A secant means a line that cuts the curve, not
Exactly
touches
the
the
two
curve.
halves, or
No, it might be
like-
more. So for example, if I have this scenario, then this is also a secant line, but it cuts the curve at many points here. Yes, but it should cut the point, okay? So this green one is simultaneously a tangent and a secant. Tangent because of the tangent feeling of being tangent around this point, and secant because here it cuts the curve. Yes?
Are secant lines infinite?
You can have infinitely, but by the way, usually you can also have infinitely many tangent lines.
No, I mean infinite in length.
No, lines are always infinite. They are not line segments. When I talk about tangent line and secant line, they always continue forever from both directions. That's a line, not a line segment. So is that clear?
Yeah.
Yes?
If we say that like two curves that go upwards are on the same height, does that mean you can have two centers of tangency?
No, there is no center of tangency at this level in
Or
high
point of
school.
tangency?
Point of tangency. So what do you mean? You have two curves.
Like we have, it's like the same curve,
Yes?
but both of them, when they reach their maximum height, it's the same height.
Yes?
They have 2 points of tangency.
Exactly. So what actually Maximilian is actually telling is actually a nice question. So what you have, so you might have this situation that when I draw a tangent line, it also becomes a tangent in another point. That's also possible. So then this is a unique tangent line, but there are two points of tangency corresponding to that. Yes. So this is why I do not want to define them mathematically, because if you want to define them rigorously, it would be a little bit harder. But every one of us have some intuition about the tangent line. So if I have drawn this picture before, and I ask you, do you think it's reasonable to call this tangent to this curve? You would say yes, this line seems to be tangent to this. So it means that we know what we're talking about. And then of course, if I ask you at which points these two touches, then you show these 2 points. Okay, instead of saying which points they touches, the terminology is that the point of tangency. So here we have 2 points of tangency, but just one tangent line. Yes.
So it was a tangent line and not a secant line also.
No, here this is, if it goes forever like this is only the tangent line.
Okay.
But if I don't know, for some reason it turns out, and then cut that one, this is also a tangent and a secant simultaneously.
Sure.
Yeah, that's the idea. The idea is very simple. Yes or no?
Yeah.
Okay, so let me stop here. This lesson is not finished yet. So I will continue this, and then I want to use the tools in GeoGebra, because GeoGebra is very good in in showing you the tangent lines. So you can ask GeoGebra to draw the tangent lines, secant lines, and of course these turning points. That would be the topic of this next session. So thank you very much.
Oh, we end now.
Yes, we end.
Yeah, at the 15th. That's it.